So this is representation of vectors, representation of vectors, representation of vectors. Let me write that like that. And we are saying that you can represent a vector, say vector AB, in that direction. So you've used two capital letters to denote vector. In this case, you are trying to tell us that the length of this vector is between point A and point B, and the direction is from A towards B. For instance, you can draw that and say this is A, this is B. This is the length we are talking about. And then the direction is this way, so we will show with that arrow. So these vectors can be represented as vector AB, which we are showing here. You can, for instance, represent vector CB, in which instance it means we are having a line from C towards B, and that is the direction, showing us that this vector, the direction is from C to B. Now, there are situations where our vectors can be represented by a single small letter. Say, you can find a vector written as vector A. Now, normally in typing, you'll write A, but a bold A. But when we are writing using our pens, it is normally A with a wavy line just below. So this is read as vector A. This is read as vector B. A. This is read as vector A. We could also have vector B, B with a wavy line just below it. We could also have vector C, which is a C with a wavy line just below it. Now, we can get all this information and write it in what we call a Cartesian plane. We can get this information and write it in what we call a Cartesian plane. For instance, drawing a Cartesian plane, you can draw a Cartesian plane this way. So this will be y-axis. Always remember to show that your Cartesian plane is continuous by drawing that arrow. This is x-axis, that is x-axis. Now, from here, we can draw any vector that way and call here point A, call that place point B. Now, from this, we can give it direction, so that is a vector quantity. And we can now decide to give this vector. Now, giving this vector, you'll say that we want vector AB that way. So this is read as vector AB. Now, giving vector AB in this case, we'll be forced to know the coordinates of point A and also know the coordinates of point B. So I would very first have arbitrary points like that. Let's call this is 1, 2, 3, 4, 5, that way. We can also have arbitrary points 1, 2, 3, 4, 5, in which case we'll have 1, 2, 3, 4, 5. Now, using this, we can get the coordinates of A, which are normally given first of all by the x coordinate, followed by the y coordinate. So we will have 1 in this case and 1. So we have point A being 1, 1. Point B in this case would be x-axis. We would have 4 followed by, let me just write it here, 4 followed by the y coordinate 3. So we have 2 points A and then we also have B. So we have A1, 1 and B4, 3. Now, working with this, we can get AB. And getting AB means we have to see by how many units has A been displaced or moved towards B. Now, in that case, we'll find that A is at 1 and B is at 4 when you look at the x-axis only. So this will tell us that the units between 1 and 4 is 3 units. So putting this, we can write vector AB as 3 units to show us how we have moved on the x-axis, and write the second part as, so we will check we've moved from 1 up to 3 on the y-axis. So we can show that 1 up to 3, that is difference in units of 2 units. So we can say that in y-axis, the movement from A to B was actually 2 units. So we can represent this vector and say that our vector AB is actually 3, 2. Now, normally when you are giving vectors, especially when you are using coordinates, make sure that you give both the x, this is the x units, and also make sure that you give the y units. So you check by what units have we moved from one point to another when you are considering the x values, and when you are considering the y values, by what units have we moved from one place to another. So basically this is how we present vectors. Told you that we can use capital letters and show direction when you are presenting vectors, and still you can use small letters and show direction. Now, to use small letters and show direction, for example, in this case, suppose we had another line starting from point 0, 0, which is the origin here. Say this line is represented by OD, that is the direction. Now, in this case, this is called a position vector because it starts from the origin or the center of the Cartesian plane. So normally we use the last letter. For example, OD, we are moving towards D. So D here is the last letter, O is the first one. We normally use this last letter to give that vector a name. For example, this vector would simply be called vector D. Normally when you're only using one letter, use a small letter. In a situation, for example, where you have another line, say, let me just rub here so that you're able to see it clearly. For example, you can be given vector AB, you can be given, say, vector CD, you can be given, say, vector EF, and you can be asked to check whether these vectors are equivalent or not. Now, just to remind us, we said when we were starting that vectors actually have two characteristics that make them vector quantities. A vector, we said, that must have what we call direction, and we also say that a vector must have the second thing, magnitude, or what we sometimes call size, or what we also call length. Now, two vectors are said to be equivalent if they are moving in the same direction and they have equivalent magnitude. So let me just note that for you. Say that two vectors are said to be equivalent if they, one, move in the same direction, and two, they have the same magnitude. So we can illustrate this further by checking an example of two vectors, which we can use to show us whether two vectors are equivalent or not.